Hello everyone. Today I'll be discussing geometry of 3 dimension, some basic concepts. And this we are going to do for class 12. So some terms which you have already done in class 11 will be used here. Like coordinate of a point, 3 dimension. So any point can be described with the help of 3 coordinate system, and the point will be specified by the x coordinate, the y coordinate and the z coordinate. All those class 11 concepts like a point on x axis will be in what form? It will be of the form x0, 0 because there is no y and z coordinate. On y axis it will be of the form 0, y, 0. On z axis 0, 0, z. So I'll assume that this much basic concept you have, and the meaning of x, y, z. X is what? Distance from the yz plane. And y is the distance from zx plane, and z is the distance from xy plane. You know, 8 octants are there. I am not going to revise the concept of octant here because as you have already done it in class 11, there is no need to waste time here. But one basic concept you need to remember, that if there is a point Pxyz, then if we draw a perpendicular, then this perpendicular on the xz plane, its length will be y. Distance where you have dropped perpendicular from foot of perpendicular of the point P on the x-axis, let it be L, and on z-axis the perpendicular, let it be N. Then what is x here? OL is equal to x, ON equal to y, and already I have told you ON equal to z and PM equal to y. This way you can understand the coordinate of a point Pxyz has this meaning. This part is x, this perpendicular length is y, and this distance ON is equal to z. There is another way to understand this. I mean, you can visualize this. If I draw a cuboid here, this is a cuboid. I am going to draw it. In this cuboid, we take the coordinate axis this manner, where there will be 3 coterminous edges are there for this parallelepiped. Those are taken as, you take it as OA, this one OB, and this one OC. If in this 3-dimensional space, because this is volume, volume means 3-dimensional space, we are taking x-axis in this direction, this is your y-axis, and this is z-axis. There is a point Pxyz, which is the tip of this line segment OP. O's coordinate you know 0, 0, 0. This one P x, y, z. Let us find the P x in this diagram. What is x over there? What is y? What is z? If we draw perpendicular from P on the x-axis, it will meet the cuboid at A. On y-axis, it will meet the cuboid at B, and the z-axis, it will meet at the point C. So this angle is 90 degree. 90 degree. This one also 90 degree. So which part is x over there? That OA is x, OB is y, and OC is z. What I have told you earlier, the same thing, we are just seeing it with different manner. If you take the point P over there, that the way I have taken, you draw perpendicular here, then this length going to be equal to x. I have taken that only exactly. This part is x, this part y, and this part z. This much concept I wanted to revise with you before we start the theory geometry what you require for your class 12 mathematics syllabus. So that perpendicular PM we have taken here. We have replaced L by A. We have replaced this N by C here. Don't be confused, please. And this one, B is the point, and this part is Y, you know. We have taken this part Y only previously. Now, this OP is what? In this diagram, OP stands for a line segment. Okay? O is the origin and P is the terminating point of the segment. Segment has fixed length. O has the coordinate 0, 0, 0 and P has x, y, z. Now, in this diagram, you can just go through this part where this line segment is making some angles with z-axis, some with x-axis, and some angle with the y-axis. I'll be taking these angles as alpha, beta, and this one is gamma. Okay? Now, let us see what is the value of cos alpha here. Cos alpha is what? You have to imagine, this is 3-dimensional space, no? What do you observe? In triangle OPA, OA equal to x, angle OAP equal to 90 degree, and angle AOP equal to alpha. So this is a right angle triangle. We can define cosine of the angle alpha. What is cos alpha here? Angle always lies between base and the hypotenuse. So cos alpha going to be x by OP. What is OP here? OP, this formula you got in your class 11 syllabus, there is proof also. That is x square plus y square plus z square. Distance between 2 points was there in class 11 syllabus. I am repeating that part only. So how can I write cos alpha here? Cos alpha is x by under root x square plus y square plus z square. So, cosine of the angle made by the line segment OP is given by this thing. That is cos alpha equal to x by root over x square plus y square plus z square. Now, in your syllabus, straight lines in 3D there. You have already studied vectors. I have taken so many sessions with you previously. This OP, we can say, is a vector. This OP, we can say as part of a line. OP is the part of a line. Line in 3D, line in 2D. In 2D, what was there? A line is characterized by its slope and y-intercept. A line in 2D you can get by knowing 2 points only. Here, you can get a line by using 2 points only, you join. But the thing is that the line can intersect planes, xy plane, yz plane, zx plane, like that. Now, the difference between lines in 2D and 3D is that in 2D there is slope of a line, but here there is no concept of slope. Slope there was angle made by, tangent of the angle made by line with x-axis. We need something like that to define a straight line in 3D. Cos alpha I have already told you. If we calculate cos beta in the same diagram, cos beta is what? Cos beta is y by x square, y square, z square. And cos gamma, if you see, because this angle 90 degree, so this will be z. Angle always lies between base and hypotenuse. Isn't it? Gamma is this angle. So base is here and this is the hypotenuse OP. So this is going to be z by under root x square plus y square plus z square. To define a line, we need these three quantities. At least two of them must be known. If we know two of them, then the remaining one can be found out. How? Because before doing that, let us name this one as L, this part as M, this part as N. So what I told you, OP is a vector and OP is a line segment. OP is a line segment. If we know something about OP, then we know something about the vector OP and the line whose part is OP here. So I'll be defining all the terms here in terms of a line or a vector. And this is your great advantage, that you have the scope to learn 3D with the help of vector. In our time, we did not get this facility. We had to study just by thinking three-dimensional space is there, no vector application was done. Everything was done algebraically. It was very difficult for a student to get the complete idea. And we studied 3D at honors level. Okay? You are doing it in class 12 because vector is mixed with it. So every part of this topic, I will be discussing a vector, a line or a line segment. Now these three quantities you have learned now, LMN, this will be referred as direction cosines. LMN are called direction cosines. Simply we can say that this is of the vector OP or the line whose a part is OP. OP is the line segment, part of that line. LMN are the direction cosines of the vector and the line also. Now, if we have defined L equal to cos alpha, M cos beta, N cos gamma, what the direction cosines? That is obvious because cosine alpha, cosine beta, cosine gamma, that we have understood. Now, the thing is that there is a very good relation among these three quantities. Once you find that relation, only two of them will be enough to get the third one. So in this, if we write L square, M square and N square and then we add them, squaring and adding, we get x square plus y square plus z square by this is equal to 1. So L square plus M square plus N square is 1. Hope you have understood. There is no confusion in it. So we got the relation among those three quantities for the vector OP or for the line. If you know two of them, LM known, then N can be determined. Okay? So if a question arises, a simple question I will be discussing with you. A line makes pi by 4 and makes angles. These are angles, pi by 4 and pi by 3 with x and z axis. Find the angle made by it with y-axis. How to get this? We use the relation. What is L over there? Cos pi by 4. That is 1 by root 2. What is M over there? We have to find N cos pi by 3. That is 1 by 2. Now, L square plus M square plus N square equal to 1. Therefore, half plus M square plus 1 by 4 equal to 1. So, M square will be 1 minus 3 by 4, 1 by 4. So, M will be plus minus half. M means what? M is the direction cosine, while angle made by the vector with the y-axis. Now, M equal to what? Cos beta. So, cos beta is equal to plus minus half. This will give us plus minus cos pi by 3. So, beta will be either pi by 3 or 2 pi by 3. Cos 2 pi by 3 negative. Minus sign if we absorb, this much trigonometric sense you have, because this we can write as either cos pi by 3 or cos of pi minus pi by 3. When minus sign is considered, okay? So this will give us cos 2 pi by 3. In fact, angle made by line, that acute one will state always, that is pi by 3. Obtuse one you can state, but normally we state about this angle, the acute one. So angle made by this vector with the y-axis is pi by 3. Hope you have understood. Now we are going to define direction ratios of a vector or a line segment. Now we are going to define the direction ratios of a vector or a line segment. First we define. We have direction cosines the way we have learned that is taken as LMN. You know the relationship existing between them is L square plus M square plus N square equal to 1. Now, what are direction ratios? Let A, B, C be any three quantities proportional to LMN, then A by L is going to be B by M is going to be C by N, because they are proportional. This is the definition. Then we will be referring A, B, C as they can be named as direction ratios of the vector OP or the line whose part is the line segment OP. Okay, OP you remember, just we have taken the previous diagram. So that is a vector that I told you. We can take this one, any line segment can be taken as a vector. So OP is a vector. We are taking this one as vector. This vector has direction ratios ABC. Then A will be proportional to L, ABC will be proportional to LMN, so that we can write this relation. Don't be confused. We are defining ABC as any three quantities proportional to LMN. Okay? I'll explain more on it, but let us proceed mathematically first. Let us assume that this is equal to K. Assume this thing equal to K. Then L is what? A by K, B M by K, and C is N by K. Isn't it? Now, since L square plus M square plus N square equal to 1, therefore, this is L, no? No. We are going to define A over there. We have taken this one K. So L is what? A by K. M we have to write. M is what? Not B. We are going to use it, no? So M is what? M is B by K. And N is what? N going to be C by K. Okay? Now N square plus M square plus N square 1. So A by K whole square, B by K whole square, C by K whole square 1, or so K is going to be what? Plus minus under root A square, B square, C square. Okay? So now we can define L. We can redefine L over there in terms of direction ratios. What is that? L is A by K plus minus A by M is what? B by A square, B square, C square. N is plus minus C by . So if you know the direction ratios of a line, then direction cosines can be determined. If you know direction cosines of a line, then direction ratios can be determined. Okay? Now, can you write the vector OP now? It is given that vector OP has length L, or you take R. OP equal to R is the vector. Can you write the tip of the vector in terms of L, M, N and R? Let us try. This is very important. How to express the vector or the end of the line segment by using the concept of direction ratios or direction cosines. We are taking, let OP has direction cosines L, M, N. This one 0, 0, 0. Now once you know direction cosine as L, M, N, then the point P can be written as LR, MR, NR. Why? I will be drawing the same diagram here, but instead of drawing the full diagram, I mean what I have done before, I am just dropping perpendiculars this manner. So our this angle is alpha, this angle is beta, these are perpendiculars. You have drawn perpendiculars here. Draw here also. This is PL, PM and PN. Then what is gamma over there? That I have already told you. OP makes an angle gamma with the Z axis. You got direction cosine L. Then cos alpha in the diagram is what? L by R. So cos alpha is L by R. Cos alpha. The point is X over there. X. Sorry. Cos alpha is X by R. Point is X over there. I mean OL is X. So X is going to be what? R cos alpha. Now cos alpha is L, so X is LR. Similarly, you can write Y is MR and Z is NR. This part is Z, which is equal to NR. So the point has coordinate LR, MR, NR. This is very important. OP's direction cosines you know, element. OP's length you know, you can write the tip of the vector. So using the vector symbol, if you want to write, then OP vector now going to be what? OP vector now going to be LR I cap plus MR J cap plus NR K cap. Okay? You can write OP vector that XI, YJ, ZK. You can also write in terms of length of the line segment OP or the vector OP and its direction cosines. Clear? Now, once you got the tip of vector in terms of the direction cosines like LR, MR, NR, then you can do many things. What are those? What you can do there? We can find direction ratio and direction cosines of a given vector. Let us take one example here. Find DRs, direction ratios, and this is of the vector R equal to 3i minus 4j plus 5k. Answer. So x, y, z you got. You can write those x, y, z as the LR, MR and NR respectively. Okay. You also can see that initially we have taken that A equal to LR. No. That A equal to LR. A, B, C, what we have defined? They are called direction ratios. Okay? So, instead of writing X, Y, Z, initially what we have taken? This one is A, this one B, this one C. AI plus BJ plus CK. These are referred as direction ratios. And LMN are direction cosines. And L you can find by using the relation that root over, similarly M and N. It is B by root over sigma A square, C by root over sigma A square. Now in our present problem then, if we say that the coefficient of IJK are direction ratios, so what is going to be the direction ratios here? Drs are 3 minus 4, 5. Then this is what is this formula? 3 by 3 square minus 4 square, 5 square is 50. Okay? Is 50. So, sigma A square, that part is going to be what? Root 50. Root 50 is 5 root 2. So, 3 by 5 root 2 minus 4 by 5 root 2 and 5 by 5 root 2. Hope you have understood. So, you got the idea of direction ratio, direction cosines of a vector or the line whose part is this vector or the line segment. Okay. Now, with the help of the concept we have got here, that tip of the vector is LR, MR, NR or ABC or XYZ, whatever you say, you can proceed to find the angle between two lines. Let us do angle between two lines. Before we start this, I would like to remind you the concept we have started with, that line in 2D and line in 3D. In 2D, slope. In 3D, now it is going to be direction cosines. Vector has different length. But if you know the direction cosine tip of the vector, you can easily write. That we have seen. Okay? So, angle between two lines, or we can state that angle between two vectors. Okay, same thing. If you proceed, they will give you the same value, isn't it? So, let me take the three-dimensional coordinate system here. That is x, this is y, and this part z. We are taking two vectors first, they are part of lines, and the formula we are going to derive here, that is applicable for lines as well as for vectors. Okay? We are going to find the angle, they are both originated from origin. We are going to find angle between these two vectors, that OA and OB. This is a vector, this one also a vector. We have to find the angle. How to? You assume that let OA vector is characterized by this thing, mod OA is R1 and this is R L1, M1, N1. We don't know. If we know the angle, then we can find the direction cosines, that is values of L1, M1 and N1. So, this one has length R1 and the direction cosines are LMN. Okay, this one say R2, let OB is specified by this length R2 and this is R L2, M2, N2. Alright? So, length you know, direction cosine you know. In the previous article, we have seen that if you know the length and direction cosine, strips can be written over there. So, this strip is going to be length R1, direction cosine L1, M1, N1. This will be L1, R1 Okay, M1 R1, N1 R1, and this part, this is L2 R2, M2 R2, N2 R2. We are going to find theta. How to? Length we know, and a line can be directed along way, another line along OB. That's why I told you, if you know it between the two vectors along the direction of two given lines, then it's fine. So here cos theta we have to find now. We go by cosine rule of triangle. In triangle AOB, in triangle AOB, AB square equal to R1 square R2 square minus 2R1 R2 cosine theta. What is AB over there? AB is the distance between 2 points. AB you can write easily, that is L1 R1 minus L2 R2 whole square plus M1 R1 minus M2 R2 whole square plus N1 R1 minus N2 R2 whole square. Agree or not? This is okay? So AB square you got, you put it here. AB square is this thing square plus this thing square plus this. So it will be L1 R1 minus L2 R2 whole square, M1 R1 minus M2 R2 whole square, N1 R1 minus N2 R2 whole square. Okay? This is equal to R1 square, R2 square, 2R1 R2, or now I will be expanding, definitely I will be expanding, but this step little bit insights I am applying. Here it will give us L1 square R1 square is M1 square R1 square, N1 square R1 square. So you take common. Similarly, for this one, and this one, you take R2 square common. Clear? And twice this thing is coming, minus twice L1, L2, R1, R2, M1, M2, R1, R2, plus N1, N2, clear, twice AB equal to R1 square, R2 square minus twice R1, R2. Now this thing is what? L1 square, M1 square, N1 square. This result is 1. This is also 1. So what do you get over there? That is R1 square, R2 square minus 2 L1, L2 plus M1, M2 plus N1, N2 R1, R2 equal to R1 square minus 2 R1, R2 cos theta. So this one getting cancelled, and R1, R2 is there. So you can write L1, L2 plus M1, M2 plus. So what we are doing there, dividing by twice R1, R2 both sides. So this is going to be cos theta. So the angle between two vectors or two lines can be taken this manner. So theta cos theta equal to this, that is L1 L2 M1 M2 N1 N2. Okay, let us solve one problem here where direction cosine, direction ratios, angle involved. Find the angle between two lines whose direction numbers are, say, 3, 4, 5 and -4, 3, -5. Are they new? Direction numbers? What are those? I haven't told you yet. Direction numbers, what are those? The direction numbers are actually direction ratios. Same thing. Direction numbers and direction ratios are the same thing. There is no difference between these two. Okay? So if you know direction ratios, you can get direction cosines from their angle. See here in this case, L1, M1, N1, the direction cosines going to be what? 3 square plus 4 square plus 5 square is nothing but root 50 means 5 root 2. So direction cosines will be 3 by 5 root 2, 4 by 5 root 2 and 5 by 5 root 2. What about this one? L2 M2 N2 here. This is going to be minus 4 by 5 root 2, 3 by 5 root 2 and minus 5 by 5 root 2. Clear? Same way. Because minus 4 square, 3 square, minus 5 square will give you the same result. That is 50, square root I have taken. Now cos theta is what? Now cos theta is L1 L2 plus M1 M2 plus N1 N2. Just do it. This is minus 12 plus 12 minus 25 and denominator square and add it. So 50. This is minus half. You got cos theta minus half. So theta will be what? So theta equal to 2 pi by 3. The angle between the two lines is going to be 2 pi by 3. Clear? So if we know direction cosines, we can find the angle between two lines or two vectors. Now, if two lines are perpendicular, cos theta you got. Lines are perpendicular. Lines are perpendicular when theta equal to 90. So theta 90 means L1 L2 plus M1 M2 plus N1 N2 cos theta, that is going to be 0. So if two lines are perpendicular, their direction cosines are related by this. Sum of their product taken two at a time is going to be equal to 0. Clear? So once you get all these things, the condition for perpendicular lines you got. But today's class I will be discussing theory, so I have to tell you how to get the condition for perpendicular parallelism. Two lines are parallel under what condition? Under what condition two lines are parallel. They are having direction, cosines, L1, L2, whatever we have taken. Under what condition they are parallel? Parallel means theta equal to 0. You will say that it is L1, L2 plus M1, M2 plus N1, N2 equal to 1. If they are parallel lines or vectors, then theta is 0. So cos 0 is 1. So L1, L2, M1, M2, N1, N2 equal to 1. But we can prove that for parallel lines, it can be proved that L1 by L2 equal to M1 by M2 equal to N1 by N2. So this is an equivalent condition of this thing, but application wise this is more useful. But how to prove it? We can prove it with the help of Lagrange's identity. We are going to learn it. To get this condition, first let us find an expression for sin theta. Since cos theta you got L1, L2 plus M1, M2 plus N1, N2, therefore sin theta is 1 minus cos square theta, you know. Put the value over there, 1 minus L1, L2, M1, M2, N1, N2 whole square. Okay. Now, this 1 is product of two 1s. This one is product of two 1s. Because 1 into 1, 1 only. But this 1 can be written as L1 square, M1 square, N1 square into that one is L2 square, M2 square, N2 square. This minus L1, L2, M1, M2, N1, N2 whole square. Now, if we write this one, if we rewrite, better to say, this will be L1 M2 minus L2 M1 whole square plus M1 N2 minus M2 N1 whole square plus N1 L2 minus N2 L1 whole square. And this thing is known as Lagrange's identity. If you expand it and subtract this square, it is going to be like this. You are a student of class 12 mathematics, the highest class in your school. Once you expand and simplify, definitely you can get this thing. So sin theta we got. Here sin theta we got. For parallel lines, theta 0 degree, therefore 0 going to be L1 M2 minus L2 M1 whole square, M1 N2 minus M2 N1 whole square plus no proof of Lagrange's theorem, Lagrange's identity required. I have just done it for the sake of understanding. In exam, don't expect details question based on it. Okay, it is just for derivation purpose. Now, sum of three squares going to be equal to 0, so they are separately equal to 0. So this implies L1 M2 minus L2 M1 0, which implies L1 by L2 equal to. Also, from second one, what do we get? M1 N2 minus M2 N1 0. So this implies m1 by m2 equal to n1 by n2. So this is your number 1, number 2. Now from 1 and 2 we get L1 by L2 equal to M1 by M2 equal to N1 by N2. This is the condition for parallelism of two lines. Okay? Today up to this, you understand the basic concept of 3D geometry, which lies in the concept of the direction ratios and direction cosines. Next class, I will be solving some problems based on this concept, then we will continue 3 dimension. Thank you.